I work to get this going. Okay. So, like I said, we're going to continue talking about consciousness, and the last couple of sections in the book talk about awareness of ourselves and the awareness that we have of others as well. Um, and so, because we, the idea here is that because we have this ability to have awareness of our own internal states, that then helps us to have awareness of others as well. And so, in contrast to our own self-awareness, though, obviously that's going to give us a lot more information. That's going to be a lot more rich. We have access to a lot more information within ourselves than we do to other people. And so, because of this, we end up having to do a lot of inferring, making a lot of assumptions about people, what's going on for people internally. And so because of this, all we have to really sort of go on is the verbal and the sort of nonverbal cues that they give us. So in watching people's behavior, listening to the tone of voice that they take and things like that, we then are able to make assumptions about, oh, what they might be really feeling or thinking, or what they actually intended to do. And so because of this, there's been a lot of study into, well, how does this happen? You know, we already struggle a decent amount with our own self-awareness, right? Going back to what we talked about on Wednesday in terms of so many things that are going on unconsciously as well. But for the most part, we're actually pretty good at making inferences and assumptions about what other people are thinking and feeling. And so being able to understand the mental states of other people is really critical when it comes to our social ability. So we can think about, you know, how important it is to be able to cooperate with other people, how fundamental it is to being able to empathize with people, to maybe anticipate people's behavior. And so all of these sort of assumed abilities that we have about inferring how other people are experiencing their own consciousness is a really important key idea to our ability to be social creatures in the world. And so our ability to infer or make assumptions about the mental states of other people is called a theory of mind. And so this term, it refers to our ability to understand that other people have their own thoughts and beliefs, ideas, desires that are separate from our own. And so this came out of work by researchers named Premack and Woodruff. They're the ones who coined this term, theory of mind. And this came about because after doing some work with chimpanzees for several years, they began to start thinking about and speculating what might account for differences in cognition between species. They were seeing, well, chimpanzees seem to have some sort of social and cognitive similarities to humans, but there isn't like this nice neat overlap. And so what is it about the difference between, you know, chimpanzees and humans, for example, that might lead to this difference in being able to sort of infer the states of another. And so this idea then, it really sparked just like this avalanche of research that is still going on regarding social cognition in non-human species that then eventually made its way to human research as well. And so theory of mind is often referred to as mentalizing in the literature, and it has considered, or it has received a considerable amount of attention. specifically in the developmental side of psychology. And so we'll talk through that a little bit. We won't go too in depth, but yeah, just to let you know, we're going to be taking more of a developmental sort of approach and talking about kids and how we learn as we grow. And so a lot of the research that has been done on theory of mind, it's been focused on whether our ability to form a theory of mind is innate. So if it's something that's just we're born with, it's automatic, it's just always been there. Or the sort of opposing idea is, well, maybe it's something that we learn and develop throughout our lives. So maybe we are kind of born with sort of this pre-wiring, right? This ability to eventually develop a theory of mind and being able to interact with other people in that way. But all of the processes aren't there yet. We have to go through life and develop them through trial and error in our experience with the world. And so for several years, there was a task known as the Sally Ann false belief task that had been used to look at children and their theory of mind ability. And so in this task, one of the more popular versions involves telling a child a sort of this hypothetical story. And sometimes they use pictures or puppets or things like that. But essentially, there is a scenario in which there are two characters, Sally and Anne. And the story sort of begins by the child seeing Sally put one of her marbles in a basket and then walk out and leave the room. And then after Sally is gone and out of the room, then Anne comes over and moves the marble. So Anne takes the marble out of the basket and then puts it in a different location, like a box. And so then after this, then Sally comes back into the room. And so the key question here that is posed to children who undertake this task is, where is Sally going to look for the marble when she returns to the room? And so in order to answer this question correctly, so to speak, in the context of theory of mind, the participants, they have to ignore their own knowledge about the location of the marble, and they have to take on Sally's perspective to give the answer. And so, oops, didn't mean to jump ahead yet. And so, in order to answer this correctly, so to speak, you have to take on Sally's perspective and the fact that she doesn't know that the marble had been moved in her absence. She thinks it's going to be right back in the basket where she initially placed it. And so essentially this task is showing us that in order to appropriately respond to this, you have to be able to understand that these two characters have different perspectives and different beliefs about the world, and that they are unique in the different experiences that they've had. And so when they first started doing this task, we found that children couldn't reliably give the answer of, oh, Sally would look in the basket, if they were a little bit younger than like 4. And so in these cases where these children were presumed to not sort of have this theory of mind, they would answer, well, Sally would look in the box because that's where the marble is, and not being able to differentiate the fact that their experience is different than Sally's experience. However, it eventually dawned on researchers that maybe this task was just a little bit too difficult for young children, and maybe it was pulling on abilities that we know don't develop until later in childhood, so like problem solving. And so maybe that was an issue there. And so when they made changes to the task, and they set it up so that infants could be involved, they found that younger children under 4, they were able to show this sort of budding recognition that there is a difference in perspective between what they have experienced and what, like, one of the hypothetical characters in the story, in the study, has experienced. And so out of this, there's been a large amount of research that has sort of plotted developmental milestones, so to speak, for theory of mind. And so that is different points along the lifespan in which we know certain abilities start to come online that are related to theory of mind. And I'm just going to talk through some of these. These aren't things that you're going to be tested on necessarily, right? This isn't child development, so I'm not going to be drilling you on, age markers and associated abilities, but just to sort of give you a sense of the developmental trajectory of maybe some more smaller order skills that then build upon each other to eventually help give us a theory of mind, to be able to infer what other people might be thinking and feeling. And so when there have been studies that have involved adults and babies, and in one of these studies, when an adult has been looking for an object and doesn't know where it is, but the infant knows where it is, the infant, once they realize that the adult is looking for it, the infant will point to it. And however, when the adult does know the location, though, the infant won't tend to point it out to them. And so this is suggesting that the babies are able to understand the goals and intentions of the adult. So when they see adults looking around for an object, they're able to kind of put together, oh, I think they're looking for something. And maybe I know what that something is. So let me see if I can help and point it out to them. And we also know that with 15-month-old babies, they show a sort of surprise response when someone searches in a container for a toy that had been put there when the person didn't know, suggesting that they understand that the person didn't know that the toy was there. So they go to the toy chest and they go, oh, this teddy bear wasn't here earlier, and the baby will also show surprise, sort of joining with that person in that surprise, because presumably the baby is aware that this person didn't know about this new condition, this change in things, until they opened up the toy chest. And so at 17 months, children have been able to show that they can understand that someone else has what's called a false belief. So that somebody has an idea of, oh, this toy should be located here, but what? It's gone. How, I thought it was right there. And around the ages of 3 and 4, children begin to have this recognition that their own physical vantage point gives them a different perspective on the world than other people's vantage point. So this idea of, oh, a difference in somebody's location means that they're experiencing events differently than I am, even if we're maybe looking at the same thing, but we're looking at it from different maybe places in the room or things like that. And then around 5 or 6, children are able to understand that their own mental state is different from the mental state of others. And then around 6 or 7, children, they start to become even more sophisticated. They can start to differentiate between somebody's literal meaning, and they can also start to pick up on if somebody is speaking more metaphorically, or if they're being ironic, if they're being sarcastic. And so this shows that they're able to step into the other person's perspective and understand more of the intention behind what they're saying, whether the person meant to say it literally just as it is, or if maybe it was a joke or somebody being sarcastic. And then around ages 9 to 11, children are able to actually simultaneously hold several people's perspectives in mind at the same time. So going from being able to think about, what are mommy or daddy thinking about this, to, I wonder what mommy and daddy and my brothers and sisters might all be thinking, and being able to differentiate, well, maybe mommy feels this way, daddy feels this way, my older brother Kevin feels this way, or maybe even being able to represent groups of classmates by this point, and to also, they also at this point start to discern when one person has hurt another person's feelings. And so even in watching interactions, maybe that they're not personally involved in, they can still infer the mental states of several people. So again, this is just sort of to give you an idea of the research that has come out to support this idea that we develop abilities that eventually lead us to have a theory of mind, and that they're stepwise. They build upon each other as we grow and develop and interact with others. And so this was pretty much how things stood for a while in the research. It was like, yep, you go through life, you develop a theory of mind. Until there were some psychologists that came up with a new task and a new hypothesis that then really challenged this idea. And so their proposal was that our theory of mind abilities are innate and automatic. So meaning that we come out of the womb already equipped to have a theory of mind, to be able to infer what others are doing and thinking and feeling. And so they reasoned that because this is automatic, it should be spontaneous. And because of this, even just the mere presence of another person should essentially sort of trigger this automatic process of trying to figure out what the other person is thinking or feeling, or what they might believe. And so they started off doing a study with adults. And so this picture is actually from the article they wrote, and I'm not sure why they decided to depict the person in the study like a Smurf, it looks like. But anyway, they're psychologists, not artists, I guess. So all to say, this shows the different conditions in their study that we're going to go through. And I don't want us to get sort of bogged down in the details. So if this explanation does get a little bit confusing, please let me know, and I'd be happy to clarify. But essentially, there were 4 different conditions that participants would experience. So all the adult participants, they saw some movie clips. And so in all of the beginning of the movie clips, they see this person on the screen who places a ball on a table in front of an opaque screen. So they can't see through the screen, but they see this person place the ball on the table, and then they see that the ball rolls behind the screen. And then 1 of 4 conditions happens. So in the first one, they see that the ball stays behind the screen while the person watches. And then after the person leaves, the ball stays there behind the screen. For the second one, the ball rolled out from behind the screen while the person in the clip was watching it. And then when they left, the ball just stayed where it was. The third condition was that the ball stayed behind the screen while the person was watching. And then when they left, the ball rolled away. And then finally, the last one was the ball rolled out from behind the screen. And then after the person leaves, then the ball goes back behind the screen. So essentially, you have these first two conditions involve what's called true belief. So what this means is that the person in the film accurately believes the correct location of the ball. So what they witnessed is actually the case. Like there weren't any tricks or changes. Nothing happened when they walked away. Versus the false belief, this again, we can kind of think back to that Sally Ann task. This is like when the marble gets moved to a new location once the person leaves. And so essentially what they were measuring here is that they were measuring participants' reaction times to the person on the screen coming back out and seeing the ball, because participants had to react to where they thought that the ball was. So not necessarily where they thought the person in the clip thought the ball was, but where they thought the ball was. And interestingly enough, the participants were influenced, their reaction time was influenced by the person in the clip's beliefs. So in the instances where the belief about the location of the ball was true for the agent, participants were faster. Whereas in the conditions where the person in the clip's expectations didn't line up, participants were slower, even though participants had seen all of the possible outcomes, and they themselves knew where it was. And so this study essentially is suggesting to us that adults track the belief of others automatically, even though they have their own beliefs and they can presumably recognize that they're different, right? And so it's this idea that there's this automaticity to us being able to take on the beliefs of others and to be influenced by them. And so again, this was done with adults. And so the question was, well, what if you do it with babies, right? If this is automatic and innate, right, then babies should do this automatically, just like adults. And so they replicated this with infants. They obviously gave them a different task. They weren't asking babies to watch video clips and respond to them. But they were using what's called a violation of expectation task. And so this is a technique in infant cognition study in which a baby's gaze time, so how long a baby looks at something, is interpreted as evidence that the baby is essentially considering what had happened there. And the idea is, if they're expecting something, right, you show them a ball, you hide it away in a box, and then you pull the ball out of the box. If you show that to them several times, they're like, yeah, okay, I get it. The ball is in the box. I'm not spending as much time looking at this because I already am aware of this. But if you put the ball in the box and you open the box and suddenly the ball is magically gone, the baby is going to spend more time looking at it because it violated its expectations of what was going to be in the box. And so the same results were found in the infant versions of Kovac et al.'s study. And so this is suggesting that theory of mind is actually innate, and that watching these researchers interact with a ball and putting it in the box, for example, and seeing the researchers interact with the ball and potentially having their expectations, the baby's expectations violated if the researcher opens the box and suddenly, oh, where's the ball? Suggests that our theory of mind is innate, and that baby was spending more time watching the researcher when the ball wasn't there because, well, what the heck? I mean, not only did I expect the ball to be there, but you did too. So what's happening here? And so in addition, these authors, they propose that being able to compute someone else's beliefs, so to respond to someone else's beliefs, to infer what they might be thinking and feeling, it might be a really core central part of our social abilities as humans. And so more recently, it's been proposed that perhaps this debate of sort of either or in the theory of mind research, in terms of, well, it's either something that is innate and automatic, you know, from the moment you're born, it's already there, versus the idea of, well, actually it develops over time. It is just a result of all of the different learning that we do as children as we go into adulthood. There's this idea of, well, maybe there's a way that both of these can be true. And this idea of this sort of both and inclusion of maybe different theories of mind came out of this sort of back and forth that actually happened in the research in like the past like 10 or so years, which is always interesting. I feel like that's, you know, maybe the pinnacle of drama in psychological research, is just sort of seeing these studies where someone specifically refuting, like calling out a specific study and saying, like, we tried to replicate this and this didn't happen, or this was an error and they didn't account for this. It's just kind of like the like, oh, shots fired of research. But anyway, all to say, so after this Kovac study came out, the one with the ball and the kind of Smurf figure in the video that they showed participants, they were criticized. There was this idea of there's this confounding variable of something about like attention and the way that it was being measured. But anyway, these researchers, Phillips et al., they were coming for Kovacs, and they're like, listen, there's a confound with your study design, and because of that, like, we can't use this as like, oh my gosh, like, this is such a huge move forward for this idea of theory of mind being innate and automatic. They're like, nope, this is a confound. And because of that, like, there still isn't that much evidence. You know, this isn't like as groundbreaking of a study as y'all thought, because there's a confound. And then a couple years later, some other researchers then were arguing against the Phillips et al. Folks. And they're like, well, we did like a literature review, and actually there is more data to support this idea of theory of mind being just automatic and innate. Anyway, just a whole back and forth. And all that to say is that this whole back and forth might suggest to us that rather than being like, well, it's one or the other, it might actually be the case that there are two sort of theory of mind systems. So, you know, it might be the case that there might be this sort of unconscious, unintentional, automatic analysis that goes on of other people's mental states, and then an accompanying process that also can become honed as we go through life, that can become developed and learned through our more explicit conscious interactions and engagements with it. But this is still unclear. So yay for research. We are just constantly generating more questions than answers, but it's all part of the process. So let's talk a little bit more about the sort of two different theories that are proposed to be going on with theory of mind. Whether or not you are a proponent of one being the case and one not accounting for theory of mind, or this both and approach. But two of the most popular ones are have to do with this first one called simulation theory. Its name has since been updated to experience sharing system theory. So I really wanted to make it difficult for you to remember. And so with this theory, it proposes that we observe other people's behavior, we then imitate it, we reflect on how it makes us feel, specifically sort of physiologically. You know, did we imitate somebody's behavior and then realize, oh, I feel kind of mad, and then that is what then helps us to infer what the other person might be feeling. And so it's through this sort of imitative process that then we reflect on ourselves of, well, how does that make me feel? Oh, okay, that must be what the other person's feeling then. The idea here is that it's really unconscious. We're not aware that we are imitating others and then pausing to reflect on what that felt like and then inferring that. But it's happening very automatically for us. And this is thought to likely be the result of mirror neurons and the system of mirror neurons that are involved with our goal-directed behavior and our understanding of the action of others, which we're going to talk about in a little bit. And then there's the other theory that has to do with a more conscious sort of approach to inferring the thoughts of others. So this one has classically been called theory theory. Yeah, not a lot of creativity there, but its name has been updated since. And so now it's more referred to as the mental state attribution system theory. Again, it's like, okay, so you either say theory or you say this mouthful, but regardless of what you call it, this idea suggests that we're able to infer people's feelings and thoughts and things like that by consciously stepping into their shoes. And so we often infer another person's mental state, but we aren't able to, this often happens, right? We can infer somebody's mental state even though we might not have clear information, or we might even be getting contradicting information, right? You know, if you're friends with somebody for a long time, you can start to infer what they might actually be feeling, even though they're telling you, oh no, like I'm fine, I'm totally fine, I'm just really tired today, just out of it. You can then infer based on your knowledge of that person, I don't think that's the case. I think you are actually upset about something because, you know, I have this knowledge of what you are like in the past, you know, when you've been really tired, you haven't acted this way, for example. And so again, we are explicitly and consciously drawing on our knowledge of these individuals that we're interacting with to get a sense of what they might be feeling and thinking. And so there's also a proposed mechanism that we're going to talk about at the level of neurons. And this is regarding how we go about trying to infer the minds of others as we develop a theory of mind. So now we're looking at more of the physical evidence within the brain for how we might go about developing a theory of mind. And I found a really great video that gives a nice overview of mirror neurons, their proposed function in our social cognition and behavior, and also some of the debate that is surrounding the research when it comes to mirror neurons and autism. I know that in the book, it was talking a little bit more conclusively about what the research has shown regarding mirror neurons and autism. But since that book is a little bit outdated, there's been some research since to suggest maybe it's not so cut and dry as we thought, in terms of, well, maybe there's just this deficient mirror neuron system, and that's what's going on in autism. It seems like it's more nuanced than that. And so anyway, I think this will give us a nice introduction to the concept of mirror neurons. And then we'll go into more depth about what this researcher, Antonia Hamilton, talks about in this video. So I'm going to stop sharing my screen for just a moment so that I can pull up the Zoom. The Zoom is already up, Katie. So that I can pull up the YouTube video I want to show you all. Okay, great. Also, she has a British accent, so I don't know about you, but I automatically feel like somebody is more qualified to talk about something if they have a British accent. So.
The problem of how we understand other people has always been a very complicated one, and even in very simple situations, if we see another person pick up a cup of tea, or we see them make a particular symbol with their hands or something, then we're often able to understand, without even thinking about it, what it is that they're doing and what it is that they mean. In the last 2 decades, there's been an enormous amount of research on this area to try and uncover what are the mechanisms in the brain that let us understand other people's behaviour in very simple ways. And there's been a very influential discovery of things called mirror neurons. It's a discovery that was made nearly 20 years ago now by neuroscientists working in Italy, in Parma. And they were studying macaque monkeys as the monkeys move and pick up a peanut. And they found that there were individual neurons in the premotor cortex of the monkey which would respond not only when the monkey picks up a peanut, but also when the monkey sees a person pick up a peanut. So these individual neurons, the sort of basic units of the brain, are linking together the actions that you see and the actions that you do yourself. And these were named mirror neurons, and this has been an incredibly influential discovery because for the first time it gave people a handle on the idea that there could be some very, very basic mechanism in the motor system of the monkey that actually allows you to do something social and link the things that you see up to the actions that you do yourself. So these were discovered now almost 20 years ago, but there's still a lot of controversy over how they work and what they do and how important they really are to our social lives. Some of the things that are very interesting in this area is the question of how important are these neurons for really understanding what another person's doing. So if you see another person grasping an object, do you have to use your mirror neurons to understand that? And we've studied how, for example, if you use a technique called transcranial magnetic stimulation, you put a magnet over the outside of a person's head and you can put a pulse through that magnet and deactivate the part of their brain that's underneath the magnet. So this is a very, very rapid thing. It rapidly just disrupts the neurons underneath the magnet. And if you do that over areas like the premotor cortex where people have mirror neurons, and at the same time you're asking people to do quite a difficult task where they have to understand another person, then their performance gets much, much worse. So we've been able to provide some data saying that maybe we think these mirror neurons, or at least these areas of the brain that have mirror neurons, are very important for understanding the behaviour of other people. and certainly we know also if people have strokes that damage these areas, then that can have quite a big impact, not only on their ability to perform actions, but also it may impact on their ability to understand other people. So the mirror neurons are found mainly in two areas of the brain, in the premotor cortex and also in the parietal cortex. There's a variety of different ways of classifying them. Some of them are very, very selective. They will only respond if the monkey picks up a peanut and also if the person that they're watching picks up a peanut. But others are much more general and will respond to a variety of actions. So it's been quite controversial as to what the mechanism is and how precise this matching needs to be in order for it to be socially useful. The other question that's been a very big controversy in the area of mirror neurons is the question of where do they come from in terms of evolution. So have we evolved to have mirror neurons, and that this could be a change from millions of years ago, that our mirror neurons got better and better and are there driven by evolution to allow us to interact with other people. Or the rival theory is that actually this is something that we learn throughout our lives, that when babies are born, they don't have any mirror neurons, but that when they see actions and when they do actions, then they make connections between the images that they see in front of them and the actual movements of their hand. And by making those connections, they create mirror neurons. And over the last few years, there's been increasing evidence that we create mirror neurons through performing actions and through observing our own actions and observing the actions of other people. A baby at 4 months old will spend about 40% of its waking time looking at its own hand because it's really learning and working very hard to learn those connections between the image that you see if you took a photograph of your hand and the movements that you make when you send signals to your muscles to move your hand. And we think that those kind of connections are part of what's setting up mirror neurons. We're doing some studies at the moment with some collaborators to look at babies, and we can now record brain activity in babies while they're learning these things and try to see these systems come online as babies develop. An important question that arose when mirror neurons were first discovered was the question of what happens if mirror neurons go wrong. What would go wrong in somebody's brain if these mirror neurons weren't there, and what would be different about them? And very rapidly there was a theory put forward called the broken mirror theory of autism, where some researchers suggested that if you didn't have these mirror neurons, that could be a potential cause of autism. Autism is a developmental disorder where children don't interact with other people in the same way. They often withdraw from other people, and maybe they don't imitate to the same extent. They don't do some of the things that you expect in terms of normal social interaction. And so this idea that these children might have difficulties with their mirror neurons was something that got a lot of popular press. But when we actually turn to look at it rigorously, we find that the idea doesn't really make much sense. So if we test the children on tasks that specifically require them to use their mirror neurons, they do fine. And we put them in brain scanners, we put adults in brain scanners and show them pictures of people doing movements and different kinds of movements, and we find that their mirror neurons respond in just the same way as other people. The brain systems that contain mirror neurons are behaving in the same way. So it's interesting to see, I guess, how this controversy has developed about how our theories of what's going on in autism need to move on, and we need to find more sophisticated models, because we know there are a lot of differences in these children, but it isn't just due to things that are going wrong with mirror neurons. So we know that macaque monkeys have a small number of mirror neurons, but the kind of methods that we use to look at whether or not you've got mirror neurons, which is either recording inside the brain or doing MRI scans, are methods that we can't do with apes or chimpanzees because they tend not to like sitting in MRI scans. So we don't know is the answer. We think it's very likely, and especially if you take the view that these neurons are learned, then they would have ample opportunity to learn this, but we don't have any definitive evidence for that yet. So we think that mirror neurons are very important in terms of helping us understand some of the very basic mechanisms of social interaction. And if we've got those basic building blocks, we can then understand how people would build on those for more complex interactions. They're also something that turns out to be very important in motor disorders. So in people who have a stroke, as I said, a stroke can affect your ability to perform actions if the stroke affects the motor cortex, but also to understand actions. It turns out there may also be some differences, things like people are looking at differences in people with Parkinson's disease who have difficulties performing movements. And this idea that the actions that you can perform help you understand other people's actions is something that seems to be very, very fundamental. So there's some very interesting studies showing that if you learn a new motor skill, if you learn a new type of ballet, then that changes your brain, that changes your mirror neuron system and gives you a much greater understanding of other people performing that kind of skill. So there's a couple of very interesting studies where, for example, we take people who have never done modern dance before and train them up over the course of 5 weeks to do a particular kind of modern dance and scan them every week to see how their brain changes, and find that then as they learn the dance, they also show different patterns and more patterns of brain activation in the mirror neuron system as they are able to understand in much more detail and in a much greater fashion the kind of dance that they're seeing when another person is performing the modern dance. So the mirror neuron system really is giving us some sort of key insights into basic mechanisms of visual motor learning and how people acquire new skills and then use those skills in a social way to make sense of other people. So the main questions in the field of mirror neuron research for the future is to understand how does this system relate to other brain systems. How does information from the mirror neuron systems feed into other brain systems that allow us to infer social things about who's nice or who's not nice or who to interact with and other kinds of social relationships. And similarly to understand the relationship between mirror neurons and emotion processing, because emotions appear in the face. Sometimes we use our own face to copy the emotions that we see, and we don't know yet how much that contributes to let us understand. Do we have mirror neurons for facial emotions? And is it the same principles that we're using in mirror neuron systems that also let us have an emotional connection with other people? And then how the whole sort of puzzle fits together into the broader idea of the social brain. So one of the key questions that came up when we first started studying mirror neurons was the question of what is it that these neurons actually care about. And there's a very interesting feature when you're trying to understand actions and make sense of actions, that an action can be understood on many different levels. So if you saw a person reaching out to a tree to pick an apple, then you could understand that action, you could represent it in your mind in terms of the goal of the action to take an apple from the tree, but you could also think about the shape of the hand without caring about what the object is. You would have the same shape of the hand to grasp an apple or to grasp a tennis ball or something else. And so it's a very important question to know, does the brain care about hand shapes or does it care about the object itself that you're taking, the apple or the tennis ball? But because these things are intrinsically linked, it becomes very hard in terms of the methods to separate them out. Every time you show a person a picture or a movie of a person grasping an apple, both the hand shape and the apple are there at once. So we spent some time devising experiments that would let us separate these things out. And we showed that if you show people the same movie twice in a row, then for the second one you get slightly less brain activation, something called repetition suppression. It means that the thing you're seeing maybe has become predictable. So if you see the same hand shape twice in a row, the hand shape for grasping an apple, then the brain activation will be suppressed if that particular region of the brain encodes the shape of the hand. But if you show the same hand shape grasping an apple, and then the next time the same hand shape is grasping a tennis ball, then because you're taking a different object, the brain activation won't be suppressed, but only if the brain actually cares what the identity of the object is. And so we were able to use this method in an MRI scanner with brain imaging to show that there's some areas of your brain that really care about the shape of your hand, whereas there's other areas of the brain that really care about what the object is that you're grasping. And so making these kind of more detailed distinctions is important, first because it will give you a much better interpretation of what's happening, for example, in people who've had a stroke or had some form of brain damage that affects one of these brain areas and not the other. But also almost on a more philosophical level, it's showing that these different concepts we have about things in the everyday world, like grasping a particular kind of an object, really are encoded in particular brain regions, and that we can distinguish within the brain between these different ideas about the goal of an action or the way an action has been performed, which philosophers might have talked about, but we couldn't before sort of see the psychological reality of these kind of concepts and see how they work in the brain. And we think that there's probably mirror neurons that deal with both of these different levels, and then you have to integrate the system together in order to have a whole understanding of what another person's action is and what you're going to do with it.
Just realized I was muted. Okay, so like I said, that is just a larger conceptual overview of mirror neurons. So now we'll just go a little bit more in depth on them, not to the extent of anything like neuroscience, but hopefully in a way that helps you to better understand how mirror neurons are involved in our day-to-day social functioning. And so as Dr. Hamilton mentioned in the video, mirror neurons were actually discovered purely by accident. There's a group of researchers in Italy, and what they were doing is they were looking at part of the motor cortex in the brain. And so they were using chimps to model this portion of the brain and to study it. And specifically, they were looking at mouth and hand movements and the kind of parts of the brain that are responsible for generating those. And so the story goes that there's this graduate student who walked back into the lab, and the monkeys were all hooked up to the electrodes and everything. And he had a cone of gelato. And so as he was, eating his gelato, Lucky, there was this surge in neural activity that was recorded in the monkeys, because these monkeys were, like I said, they were hooked up. It was live recording, and he was just coming back probably from a break or something like that. And so these specifically the neurons that were activated were the neurons that are the exact same ones that that would become active when the monkeys would grasp and move something to their mouths. Even though in this instance, the monkeys weren't moving at all. In fact, the monkey was so focused on what the researcher was doing, what this graduate student was doing, that they weren't moving at all. And so they had previously demonstrated in this lab that there are certain brain cells that show an increase in activity when these monkeys would perform these sort of goal-based actions. So like grasping a banana and tearing it open. And that was sort of regardless of whatever the context of the situation was. So regardless of whether the monkey was by itself or with other monkeys, for example, the same cells were firing for when it would grasp and tear open the banana. And so what they were seeing with this gelato incident with this grad student was that all it took was just simple observation for these same motor cells to come online, to be activated. The same motor cells that these monkeys would use if they themselves were eating the gelato. And so they started trying to study this further. And so, for some of the future experiments that they did with these monkeys, they had them view different objects. And so on some of the trials, the monkeys, they would do a certain action like reaching or grasping for an object that they wanted, like a peanut. On some of the other trials, the monkeys observed the experimenter making the same actions. And so they essentially found that exactly the same neurons were firing when the individual monkey observed a researcher reaching for a peanut, as when it did the same movement itself. And so this is suggesting evidence for there being a link between our perception and our actions. And these neurons that they started to hone in on in the study were appropriately named mirror neurons. They were neurons that were representing or reflecting the motor movement of another. And they were the exact same ones that these monkeys would use to do that same movement. And so there's kind of this critique at first of this idea that was brought up of, well, isn't this just evidence that this is just connection between vision and motor abilities? How can we actually say that this is going to support the idea of this theory of mind and our social cognition and our ability to infer about the states of other people? And as Rosalotti and colleagues continued studying this, they found that the answer was no. So they found things like the same neurons would be, the same motor neurons would be activated by just the mere sound of a peanut cracking open, in comparison to when the monkey was eating the peanut themselves, or when they saw the researcher eating a peanut or grasping a peanut. Their mirror neurons also became active when they were watching the researchers grasp for a peanut that they knew was behind a screen. And so their mirror neurons became active despite the intended goal of the action, right? Grabbing the peanut. They didn't see that happening, but yet they still had this this neural activity pattern that seemed to suggest that they did know what was happening. And so this brings us to the idea that the activity in these mirror neurons, it was connected to the goal-directed activity, regardless of how it was being experienced by these monkeys. So whether they were watching directly with no obstructions, the experimenter just eating some peanuts, whether they heard the peanuts being cracked open, whether they saw a researcher reaching for a peanut where they knew it was, but they couldn't see it. And so it seems to be more than just this connection between our vision and motor abilities. It seems to be more about the connection between our perceptual and our motor abilities, our awareness of our surroundings and the ways in which one can possibly interact with those surroundings. And so the intimate link that I was talking about between our perception and action is really underscored by this finding that our comprehension of the actions that are being done by someone else that we're watching, they depend on the activation of the neural structures that would be engaged in ourselves. And so there's sort of, again, this idea of this codependency between our perception and our motor abilities. And so researchers then began to speak of this system, this mirror system of neurons that are distributed in networks all throughout the brain, but particularly regions that are involved in action and comprehension. And so, like I said, the perceptual system isn't separate from our action system. There's this connection between the two. And so our brain doesn't have these abstract representations of visual patterns of, oh, that is a hand grasping, and then it does this, and then it opens up a peanut shell and eats it. But rather, our comprehension to understand the actions of another person involve referring to our own ability to do that particular action. So mirror neurons give us this idea that our comprehension of another person's internal state, their intention, their feelings, are self-referential, meaning that we have to look to ourselves to try to then understand others. And so this notion of self-reference is sometimes referred to as embodied cognition. So our conceptual knowledge is grounded or rooted in our body knowledge, our physical knowledge. Also, like Dr. Hamilton was talking about in the video, and this is just further support of this idea that we have to look to ourselves in order to understand others, is the extent of our experiences that we've had then influence the extent of our mirror neuron activation too. So she was talking about some studies with dancers, and there have been some neuroimaging studies that have been done where they brought in skilled, more classically trained dancers, and they had them watch videos of maybe a particular routine that they knew or a style of dance. And they saw that these dancers had more mirror neuron activation than people who were not so familiar with dancing. And so again, this idea that our own experiences then influence our understanding of what might be going on in others as well. And so our mirror neuron systems have been implicated in more than just our understanding of how we go about producing motor actions. And so many researchers have argued that this ability to have a theory of mind and this ability to stimulate within ourselves what might be going on in others is really foundational for us to learn new skills, for us to understand and maybe even predict the intention of other people, and also provides a neural basis for empathy as well. You know, this idea of, oh, I'm feeling what you're feeling is thought to be connected to our ability to make inferences about other people. So in conclusion, just real quickly, just reviewing what we have talked about so far in this chapter regarding consciousness. So like we've talked about before in previous chapters and this chapter, many of our mental processes are carried out without our conscious awareness, right? Although we know that events that are more demanding, so new tasks that we've never done before, for example, they require more of our conscious involvement. And we also know that with practice, right, we can develop automaticity of some of these certain cognitive processes and even like daily routines that we just know how to do without giving it much of a second thought. And so going in just a little more philosophical sort of a direction for a moment in this idea of consciousness, these researchers, Koch and Crick, they were like, well, I mean, we're so, human cognition is so automatic. So what is it that's sort of stopping us from being these automated zombies or just sort of automated robots who are just going through? And so the answer here is that it's actually our consciousness that both allows us to go through life with some automaticity, while at the same time having enough conscious awareness that we can have this sense of agency and not being sort of automated robots. And it's also sort of this nuance of our consciousness that allows us to have a stream of consciousness and a sense of continuity as we go throughout our lives. And that's where we will go ahead and stop for today. I know that we are over time, so thank you for sticking with me. Anybody have any questions before we go? I just had a question on if we're going to be tested on like the theory of minds and the mirror neurons on the test that's next Wednesday, or if that's for the next test. That's going to be for the last test in this class. Mm-hmm. Okay. Yeah.
Thank you.
Yeah. Wednesday's test is just chapters 6 through 9. So. All right. Well, it was great to see you all. Take care. Enjoy your weekends, and I'll see you on Wednesday.
Thank you.
Bye.
Thank you.